have it, but he's an inventor. He's a member of American Society of Civil Engineers, American Chemical Society. He was up to a nominee for an award, environmental award, and we're looking forward to hearing about the soil stabilization technique that you have. Robert, the floor is yours.
Thank you, Camille. I appreciate the introduction. The one thing Camille did not mention is I just consider myself a clever kid from New Jersey, and I'm honored and flattered to be in front of you fine people. Yesterday I participated in a presentation. Ryan was part of it, very esteemed colleagues, and my takeaway I processed as the 3 C's: carbon, cost, and convenience. And thus far, in what I've heard throughout the IRF convention, those are the 3 components that we need to be mindful of. I'm going to try to go through this quickly. Brief introduction. We have, let's call it a suite of products. Roadmaster, which is for soil stabilization, and I'll get into that. AggreDust, which is for dust control and essentially surface stabilization. AggreSeal, which is a high-power hydrophobic sealer for walls, blocks, bricks, and pavers. We have AggreBlock, where you can make blocks, bricks, and pavers from in situ material. And then AggreCoat Silver, which is an antimicrobial coating. I put a little time into, when did soil stabilization begin? I don't want to burden you with all those details, but the fascinating thing is, it began about 5,500 years ago. I always thought soil stabilization began the day after the wheel was invented. It in fact began probably the week after they were able to stabilize 2 wheels on a vehicle, and they needed the Bronze Age to be able to make an axle. We now have the axle and the wheel. What do we do with it? There are numerous challenges. What our proprietary chemistry does is it enables us to work with a wide bandwidth of soils. And when you calculate all the variations, there are about 300 variations on a theme. In my hand here is just plain, basic Texas dirt that's been soil stabilized with our chemistry. You can put on top of this a wearing surface, or you could have it be where is, as is, for low volume rural roads, haulage roads, agricultural roads. This is a high clay content soil that comes from the state of Mato Grosso in Brazil, the Amazon basin. It's fertile agricultural land. We work with waste material, we work with hazardous waste material. We do not require cohesive material to soil stabilize. Now, there are numerous challenges in the world of soil stabilization, in the world of road manufacturing. There is a global shortage of sand. That's the right sand to be able to make cement, concrete, and do stabilization. Then we talk about aggregate. There's a shortage of aggregate. Now, some areas of the country or the world are rich with aggregate, others are not. Last paragraph. Sometimes the distance covered appears to be extreme. You have to bring it in by water or by barge to regions that don't have aggregate. That adds cost. The next thing is, and this is just the beginning, it took me less than 30 seconds on an internet search to come up with these articles. There's a global shortage of aggregate. There is pressure to thwart the quarrying of aggregate. So now, what do we offer? And what we offer is our proprietary long-string cross-linking styrene acrylic polymer. What we do is we coat the particulates of the mass and we force them together in the process of building a road. Right here is in situ material. You may or may not need to amend the soil, bringing in some finer soils. Then you would mix our admixture, the AggreBind and water, in a 5:1 dilution, water to AggreBind. You need only 4 liters of concentrate per cubic meter. That's 4 kg of weight to a cubic meter. A cubic meter weighs about 1,800 kilograms. So it's a minuscule percentage. The measurements would be 1 gallon of concentrate per cubic yard at a 5:1 dilution. You introduce the admixture, you homogenize the soil in 0.4, and then you force it together through compaction. And when the coated particulates of the mass touch each other on a molecular level, they grow long strings or fingers to create a 3-dimensional interlocking chain. I'm going to go through the science real fast. What's the net result? We increase the CBR, the load-bearing strength, from 400%, and that's 448, to 600%, and that's 694. We exceed the statement of 400% to 600%. That's the range. We've been tested worldwide. In Cameroon, we were tested by the Technical University of the country. We've been published in the Cameroonian Journal of Science. We've been shown to go to 600%. They're able to take a class 4 soil, make it a class 5, thereby eliminating the need to import. That's the science. Now we need to talk about where the tires hit the road. With AggreBind, what you have is a solid block. It is water resistant, hydrophobic. You can add on top of that a wearing surface, such as a micro pavement, asphalt, concrete, chip seal, bitumen emulsion, slurry seal, as the situations require. For a rural application, low volume, farm to market roads, it could be all in, and you just surface seal it with AggreBind. Now, because we create that solid block, you notice this is a flat surface right here. Unlike crushed aggregate that gets rolled into place, there are no crevices. Very simply, you can use less than, you can reduce your asphalt consumption or your concrete consumption by 12 to 20%. And when I quote these numbers, I err on the conservative side. We believe you underpromise, you overdeliver, so your actual numbers can be higher. Now, for roads, you have your base material, your subbase, you have the middle layer of soil, which we will stabilize, and you have your choices of wearing surface should the situation require. Process, going to give it real fast. Rip the road, scarify it, fluff it. If the soil needs to be amended, maybe a little aggregate, maybe a little bit of fines, you bring it in. The majority of our installations we use as is, where is, in situ material. You may need to pre-wet if the soil is dry. Then you introduce our admixture. You homogenize it with the motigrator. When it's all homogenized, you use the articulating grade of the motograder to put the road back in place with the proper camber. You run a vibratory compactor, first up and down static mode, second vibrate up and down, third static mode. And when you do that, you're forcing the coated particulates of the mass together. And that's where, on a molecular level, our chemistry grows long strings or fingers and creates that interlocking chain. When that's all done, you apply the AggreBind surface seal or a binder if you're putting asphalt on top. Everything I'm presenting here, if you contact me, I will send it to you by email. I have my cards in the back of the room, some literature, and some more samples to share. At a depth of 150 mm, 6 inches, our chemistry, because we increase CBR by 400% to 600%, will support the top-down load of a 40-ton truck. 200 mm, that's it, 8 inches, 80 ton. 250, 10 inches, that's 200 ton plus. We've gone up to 35 centimeters, 350 mm, doing mining work. When the trucks are as wide as this room, carrying 500 tons. Now, I'm going to show you examples. And we've been doing installations for many years. Our oldest installation right now is in Romania. It's been there since 2008. Our chemistry can withstand temperature ranges from minus 57 C to plus 165. And if it's plus 165, we have bigger problems than our road. I'm just going to give you 3 samples here. This is Kathmandu, Nepal. They needed to do the widening of a highway. So we've used on-site material that's after. This road supports 100,000 vehicles a day. It's the national highway connecting Kathmandu, Nepal to India. The Guatemala airport. This is a regional section of the private sector of the airport. That, in fact, is a plane lot for parked planes. And they were able to drive in the stakes and the hold wires so that they wouldn't move in the wind. That's been installed since about 2013. When we were doing the parking lot, we were basing it on on-site material. When they started ripping, they found all these pavers which had to be hauled out to the dump. And the contractor said, hey, I'm doing a foundation of a 15-story building in the city. And instead of hauling that excavated dirt to the dump site, we brought it to the airport. One of my favorite words is repurpose. We repurposed what was heading to a dump site into a road. We work with waste material and hazardous waste material. New Zealand. Ugly. What they had here was, this is Highway 27. It carries 20,000 cars a day, 4,000 trucks. There is a stretch of about 200 meters that has a very high water table. And as the trucks would go over, they create like a diaphragm motion that pumps the water upward from the high water table and causes the corrosion of the base. They had replaced and repaired the base like every 90 days. It was just an ongoing project. They brought our chemistry into the picture. We wound up milling the road, as is where is, with a grinding attachment on a skid load, just was grinding it and concurrently infusing our add mixture into the 15 centimeters that we were grinding, homogenized it, meaning mixed it once more, went back, planed it, profiled it, compacted it, top sealed it, waited an overnight, and then put chip seal on. And that was in place for about 3 years. And then I had to redo it because of the high water table and the hydrostatic pressure coming up. Potholes. Cause of potholes is the breakdown of the soil. What causes the soil to break down is moisture. The water goes in, then the water has to come up. In very hot climates, you can see the road steam. Why is the road steaming? Because of the ingress of water. In very cold climates, you have what's called frost heaves. That's where the water below grade freezes, like water in a tray in your ice cube. The water expands when it goes below freezing. If it's in the ground and it freezes, the water will expand, bubble up, and crack the pavement. City of Bridgeport, they get approximately 1,000 pothole patching requests a year. It's a lot. Potholes. We've been used effectively in Mumbai. Now, to repeat, we are the only long-string cross-linking styrene acrylic polymer on the market. We increase the load-bearing strength by 400% to 600%. We use water as the delivery system. We are non-hazardous, non-toxic, non-flammable, safe to flora, fauna, and wildlife. We are resistant to almost all spills. EPA compliant, we can encapsulate hazardous waste. And our temperature range again is -57°C to +165, and at 350 degrees Celsius, we carbonize. These are some of our international certificates. Environmental attestations that include U.S. attestations. In the U.S., we've been approved by Texas Department of Transportation. We've done work in California, Oklahoma. We were just, and you'll see shortly, selected by name by the Pennsylvania Department of Transportation to seal acid-producing rock. It's one of my favorite slides. I say thank you to the International Road Federation, and it shows the disparity of roads. And we talked about that yesterday. High income, upper, middle income, they have roads. They have the money. They have the economic resources to bring in the mechanical resources to build a road. The lower income countries and low income countries, developing countries, and low income sections of the United States, it's a ubiquitous problem. They just don't have roads because of cost. Why? Cost of material, cost of importing aggregate, cost of bringing in sand. So one of our key value propositions is we work with local material. Interesting statistic. And some of these years are dated, but the numbers really haven't changed. Back a decade ago, I calculated the amount of unpaved roads in India. I counted each of the 55 or 50, back then it was 55 countries, now it's 57. And I came to 1,900,000 kilometers of unpaved road. Then I went and looked and said, gee, How many unpaved roads are there in the United States? It was 201 million kilometers of unpaved roads in the United States. I found that a striking number. I just came back about 6 weeks ago from Querência, Mato Grosso, Brazil. This is considered the heartland, the breadbasket of Brazil. The majority of the country's cereals come out of this region. Middle picture is me sitting in the back seat of a car, driving through the region. There were moments you couldn't see beyond my arm's length because of the ambient dust. Interesting statistic. We talked about health, the impact of dust on health. There have been studies in Costa Rica that have shown 70% of elementary school children, 5th grade and below, have respiratory problems caused by dust. The playground, they're in dirt floor classrooms. Using our chemistry as a surface seal mitigates that problem. There's so much at play here. This is an agricultural haulage road. Morocco. I think it's self-explanatory. Now, that sample is from work we're doing in Saudi Arabia on an Aramco project. It was an Aramco trial. Sparks, their design city, one of the roads. We're using wrap and in situ material, on-site material, to make the road base, and then they're putting a wrap surface or asphalt surface on top. This quotes UK, United Kingdom road classifications. An A road would be a primary road that you would put asphalt or concrete. A B road would either be self-sealed, bitumen emulsion, chip seal, or a micropavement. And C are the rural farm-to-market roads in a developed country, secondary or tertiary roads, more tertiary. That's the job where we put a 5 centimeter thickness on because we had a level base. We didn't have the peaks and valleys of crushed asphalt. That's a base for a concrete road going into the Ukraine. That was a few years ago. I believe there'll be more work there soon. Encapsulation. We were tested in 2014 to encapsulate hazardous waste. This test was performed by a company that sells filters to the oil drilling industry. And it shows that AggreBind encapsulates effectively, preventing the infiltration of water, which implicates full covering of the filter sample. There was zero leaching and zero absorption of water. And in the conclusion, it also says that they feel, subject to further testing, our chemistry could be used to encapsulate NORM, naturally occurring radioactive material. Of all the things we've worked on in our workshop, we're not working with naturally occurring radioactive material. Now, from this, in 2014, we are specified by name by the Pennsylvania Department of Transportation to encapsulate acid-producing rock. We've been recently in conversation with the Ministry of Forestry of British Columbia, working with the University of British Columbia, and what came out of the collaboration is, for me, a significant term: moisture management. That's the key for preventing forest fires and developing new areas of the forest. We can be used to prevent the migration of the debris here from entering the water, and we can create a water repellent layer. Again, the word repurpose. You can make roads from fly ash, lime waste, waste concrete, wrap, and a ton more different items. Iron slag and AggreBind, wrap and AggreBind, chrome steel slag and AggreBind. Road, parking lot, parking lot. This is stuff that would have either been idle and standing in piles. Dust mitigation, that's controlling the surface. Coal terminal in Guatemala. The middle one is a Turner construction project for the expansion of the Kampagowda International Airport in Bangalore, India. Los Angeles Power and Water Authority. That was done in 2017. My last contact with the man was more than 9 months after that, and the dust control was still in place, doing what it's supposed to do. Saudi Arabia, and they have plenty of sand. You can do slopes. You can prevent the erosion. And this is one of my favorites. Based on the dilution rate, not the 5-to-1, but an 11-to-1, you can use it as a topical on a slope so that vegetation can grow. Now, dust control for specific roads. And believe me, I ate a lot of dust to come to this. You look at the width of a road, you look at the width of a tire, the amount of actual surface contact of the tire on the road is about 30% to 40%. So 60 to 65% of all roads have no surface contact. They're just there. So when it's a low volume road and money's the issue, which it always is, surface seal, dust control the road, and if over time, 3 months, 6 months, 9 months, you have wear, it's only down the middle of the road. What causes dust on the road is the convection movement of air under the truck's chassis. A truck going down the road is a moving wind tunnel. Wind farm, it's now 6 months it's in place. Temporary parking lot in Wildomar, California. We can be used for making blocks, bricks, and pavers. The bottom is block work done in Myanmar, Nepal, Central America. You don't need my pitch again. We have plenty of videos. You're welcome to contact me. Thank you very, very much.
Thank you, Robert, for a very informative,
Thank you.
interesting one product.
Yes,
solution.
with one product?
Yes, we did. Thank you.